Okay, I've got a trigonometric identity here, and I'm going to solve it with that calculator. And it's a Pythagorean identity, and because I'm not using a calculator, the ratios will end up being things that we already know. So first thing I notice is I've got sine squared x and cosine x in here, and that's going to be a tricky one to solve. So as soon as I see the mix between these and these, I think I'm going to have to use an identity in here. So the identity I want to use is this one here. Cosine or sine squared x plus cosine squared x equals 1. So I'm going to replace this sine squared x with 1 minus cosine x squared. So we end up with this 4 minus 2, and here we've got the sine squared x, so I'm going to replace that with cosine, 1 minus cosine squared x, minus 5 cos x equals 0. Now when I expand this, this is minus 2 times minus cosine squared x is going to give me 2 cos squared x's. 4 minus 2, that's going to give me 2 x's, positive 2 x's, equals 0. So I've got the minus 5 cos x still there. I've got the minus 2 times the minus cos giving me this one here, and the 4 take away 2 give me the plus 2. Now this is now a quadratic equation, and I can actually factorize this with a little bit of thinking. It's going to give me 2 cos and cos x equal to 0, and you can have a little look at this, but this one's going to give me minus 2 and minus 1, because then that gives me the minus 4 minus 5 cos x and the plus 2. Now if we take the first bracket, we've got 2 cos x is equal to 1. I want to make it equal to 0, remember, and solve it. So this now is going to give me cos x equals a half. Now cos x equals a half when x is at pi over 3, and the other one will be 5 pi over 3 and multiples of that. If I look at this, I want them from 0 to 2 pi, so that's fine, both of those work. And the other one I want is cosine x equals to 2. And I'm going to put this down even though I know now here x actually has no solutions. So the two answers I want are just the ones I worked out up here. So those are the only two answers that work. It's very, very common when you mix up the sine squared x's and the cosines that we use this identity.